All right, now I'm going to do a video for section 4.4. This is the one dealing with applications of linear equations in two variables. So word problems. I'm going to do two videos. One of them is going to be just getting these set up. That's kind of the new part. And then the other one, I'll go in and finish solving them. Okay. All right, so these are going to be applications where a system of equations would be a good way to solve it. So what you're going to do is do a quick read of the problem. It's okay as you go to just think, oh, well, sum means plus, less than is going to be subtraction. But really what you're doing is trying to get the gist of how to set things up, what to let your variables represent. So when I see a smaller number and larger number referred to, and I see that the question is, what are the numbers? That kind of gives you an idea of what to let your x and your y be, okay? So you'll have a spot where they'll do something like this. They'll have like smaller number, and they'll have a little box for you put in the value of the smaller number, and they'll have larger number. So it also works to look at that in ALEKS to give you a sense of what to let your variables stand for. So we'll let x be the smaller number and y be the larger one. And then notice how there's two sentences. So I'm going to take the first sentence and translate it. So it says the sum of the two numbers is 64. So think is 64. Think about how the sum just means if you were to add the two numbers, you'll get 64. So that's the first equation. Right now, the second equation says the smaller number is 6 less than the larger one. Remember to start where the word is located. Let me do it right here, right next to this sentence. Okay. So the smaller number, I used x for that. The smaller number, that's the x, is my equals. Then larger number is my y. And as I back up, I need 6 less than that. So it'd be minus 6. So my second equation is going to be x equals y minus 6. Okay. Now, in the next video, I'll finish solving it, but the gist of it will be that we'll take y minus 6 and be able to plug it right in there for the x in the top equation. But let's work on the setup. Let's look at this question. Here's another style. Okay, at a basketball game, a vendor was sold a combined total of 180 sodas and hot dogs, and we know that the number of sodas sold was 2 times the number of hot dogs sold. And our job is to find the number of sodas and the number of hot dogs. So as I read through that, I'm really looking for what to let my variable stand for. So I'm going to let one variable represent the number of sodas sold. And then I'm going to let the other variable stand for the number of hot dogs sold. Okay, and then there'll be a box for you to put in the value you get for each of those. So let's just let x be the number of sodas, let y be the number of hot dogs. All right, now you go back and you write, you need 2 equations. If you have 2 variables, you need 2 equations to be able to solve those. So my first equation is going to come from this sentence right here. A vendor sold a combined total of 180 sodas and hot dogs. So the number of sodas together with the number of hot dogs has to be 180. So the number of sodas sold plus the number of hot dogs sold has to be 180. Okay, so that came from that first sentence right there. Now, my second equation is going to come from this sentence. The number of sodas sold was 2 times the number of hot dogs sold. Okay, so here's the equal sign. Was. That's your equal sign when you have the form of B. On the left side, it says the number of sodas sold. So that would be X. On the right side of the word was, we have 2 times the number of hot dogs. So 2 times the number of hot dogs would be 2y. All right, then we have our system. Okay, so that was the second equation. So we have our first and our second equations, got our system. Now what we're going to do in the next video would be notice that the x's would be the same. So right there where I have an x in that first equation, I'll be able to put a 2y. All right, let me set up another type. Okay, so here we are at a theater where a couple buys a large popcorn and 2 drinks for $12.50. One large popcorn and 2 drinks cost $12.50. And then another group, a group of teenagers, buys 2 large popcorns and 5 small drinks, and it costs them $28.50. Remember, what you're really doing right now is looking at what to let your variable stand for. So the question is, find the cost of 1 large popcorn and the cost of 1 small drink. So let's let x equal the cost of 1 large popcorn Oh, I didn't really even ask the question on that one. I need to do that. No, I did. Find the cost of 1 large popcorn and the cost of 1 small drink. All right, and then y would be the cost of 1 small drink. Okay. All right, now think about how on both of these situations, you got people buying stuff that turns out to equal an amount of money, that the total cost for those things. So like this is the first sentence. It says the couple buys a large popcorn and 2 small drinks and it costs them $12.50. So $12.50 is the total cost for that one. Now think about how this would work. Like typically you see a menu that gives you the price, unit price for something, the price for one thing. So there would be a menu that would have the price for 1 popcorn and the price for 1 drink. So the cost of 1 popcorn is just going to be 1 times whatever the price for 1 popcorn is, but 2 drinks would be 2 times whatever the price is or the cost is for 1 drink. So X and Y are the costs for just 1 drink. It's like the unit price. Now the other group bought 2 large popcorns. So if X is the cost of 1 popcorn, then you need 2 times that. Y is the cost of 1 drink, but they bought 5 drinks. So you would multiply by 5, and then those should wind up equaling what they spent, which was $28.50. So now we have a system of equations. This one, you notice, has the X and the Y on the same side. This will be one where the addition method would work best. And we'll finish it in the other video. I want to set up one more. This one is in the homework, and it can be a little harder to figure out. So we have this trainer that has 2 different workout plans that he does with his clients, plan A or plan B. The clients choose, will do one or the other. They don't do both. And so what happens here is on Monday, there were 5 clients who did plan A. There were 6 who did plan B. And then we have the information for Tuesday. On Tuesday, 2 clients did plan A, 2 did plan B. What's hard about this is the information that you need is not all together within one sentence. Okay? We have this third sentence. Trey trained his Monday clients for a total. So Monday was a total of, let me do that in green since that's Monday. Monday was a total of 8 hours. Tuesday was a total of 3 hours. Now, the question is, how long does each of the workout plans last? Okay, so the length of time for plan A, like how long does he spend for plan A? And then the other thing we need is the length of time for plan B. So that tells you that letting the variables stand for those quantities would be a good plan. So what's going to happen here is I'm going to have one equation that deals with all the Monday information, another one that deals with all the Tuesday information. So on Monday, we know we had 5 people who did plan A. Okay, 5 people did plan A. We don't know how long plan A is yet, but we had 5 people that did it. Okay, plan B takes Y time. And on Monday, there were 6 people who did plan B. What we know is that Trey worked with his clients for a total of 8 hours. And he works on them individually, okay? So if we add up 5x and 6y, that will add up to be 8 hours. All right. And then for Tuesday, we know that, where is it? 2 clients did plan A. So that would be 2 clients. So he'd spend that much time with them. So 2x would be the time he spent with the people doing the A workout. And he had 2 who did plan B, so 2 times y. And he worked for 3 hours on Tuesday with those clients. So now we have a system of equations. And so from there, we'll be able to solve that and find out how long each of those took. Okay. So we'll stop this and make a separate video on the solving.